Here's question 3. It's a multiple choice question, but don't let that fool you. Don't think that you just guess at what the right answer is. I just did that so that it would be easier for you to enter your answer. So let's actually work this out. We've got a quadrilateral here, a rectangle, and you've got the corners of the rectangle which are cut off in the shape of triangles. Now we're trying to find the area of this quadrilateral here. So if we find the area of the full rectangle and we take away the areas of the triangles, we'll be left with that quadrilateral there in the middle. Now we don't actually need to work out what its size is because we don't have enough of the given information. We don't have all of the lengths, but we need to write an expression for the area using x, okay? Okay, so here you see I've drawn my diagram 3, and I've got a rectangle which is 10 by 8 minus 4 triangles. So I'm going to start by writing angle A, or shape A, has got an area of a rectangle minus 4 triangles. And now be careful because these 4 triangles are not all the same size, so I do have to work out each one of them and subtract them from the rectangle. So starting this off, I do know the area of my rectangle, length 10 times width 8, that's going to be 80, minus, now let's start with this triangle here. I can see that this height is x, and this base, I'm not sure what it is. I know the whole thing was 10, and this much is x, so x has been cut off. So this triangle has got a base of 10 minus x, and a height of x, I'll put that out front, that's a bit easier for us to do, divided by 2. Base times height divided by 2. And I need to minus as well. Let's do this triangle next. Now this one you can clearly see the base is x, but we're not so sure about the height. The whole thing is 8, but that much is x. So this must be 8 minus x. So I'm going to do base is x, height is 8 minus x divided by 2. Okay, so I'm shading them as I go so you can see what I've done so far. Next I'll shade this one in. That's the next area I'm going to subtract from there. So minus, and again, I don't know this length for sure, but I know this is a rectangle, so the whole thing is 10 on the bottom, the whole thing is 10 on the top. This must be 10 minus the x that I'm cutting off there. So this is going to be 10 minus x again. And again, I'll put the height in front because it's easier for me to multiply through my brackets there if I've got the single term out front. 10, or x brackets 10 minus x over 2. Don't forget this is a triangle, so that's base times height divided by 2. And I've got one more triangle to do. It's a good thing that I'm shading these as I go so I remember what I've done so far. I'm doing this last one here. I can see that if we call that the base, that's x. This I'm not so sure about, but I know the whole thing is 8, and that is x, so this must be 8 minus x. So again here I'm going to do x times 8 minus x divided by 2. Right, now that that's a bit clearer, I've got 80 minus. Now I could actually simplify my working here. I don't know if this is going to confuse some of you or if it's going to help you with your working, but I've got x times 10 minus x over 2, and here I've got another x times 10 minus x over 2. If I put those two together, they're both half of x times 10 minus x. Together that would make one whole x times 10 minus x. So that might help with your working if I just write this as x times 10 minus x. Instead of dividing by 2 and putting 2 of those, I've just written that as it is, right? It's like timesing this by 2, which will cancel out that 2 underneath. Okay, and then I've got x times 8 minus x over 2 and another x times 8 minus x over 2. I'm just going to write that as a single x times 8 minus x. Just like multiplying this by 2, so canceling out that 2, and I've grouped them together there. So it's just x times 8 minus x. So that makes things a little bit simpler for me with my rearranging and my simplifying. So it's 80 minus, multiplying this through, that's going to be minus 10x. And be careful with this double negative. Negative x times negative x is plus x squared. Minus, and then I'm multiplying the x to the 8, minus 8x. And again, double negative. Negative x times negative x is plus x squared. Okay, simplify all that. And I like to have it in the right order. So I'd like to have my x squared term first, and then my x term, and then my number term. So looking at my x squares, I've got x squared and another x squared. They're both positive, so it's plus 2x squared. And then I'll look at my x terms. I've got negative 10x and I've got negative 8x. So I'm going to have negative 10 minus 8, that's negative 18x plus 80. Okay, so you can select that option from your multiple choice, but you've got to do the working, don't just guess at it. On the exam, they would not give that to you as a multiple choice. Right, question 4 now. We're given that a is 2x squared minus 18x plus 80, and we need to find the value of our x where a is a maximum. Then we want to find what that maximum value of a is. So these are two separate questions that I know we sometimes confuse, and we do them as just one thing. So let's show the working here. Right, so I'm down here at the bottom of my page, and I'm question 4. I've got an expression or an equation for a, and I want to find when a is a maximum. Remember, our maximums and mins are when we do dy dx and it's equal to 0. So we want to find x when dA dx, because we're differentiating a, not y, is equal to 0. Okay, so I'm going to differentiate this over here. dA dx is going to be taking that power, multiplying it out front, and then taking 1 away from the power. Now, I know some people are still struggling with this. They're sometimes forgetting to take 1 away from here, or they take 1 away from here and then they differentiate a second time or a third time. I'm writing here so that's clear. I'm already differentiating. I don't need to differentiate twice. I might differentiate and then simplify, but I will not differentiate again. Okay, so I'm taking my power, multiplying it out front. So it's going to be 4x, right? I did 2 times 2 makes 4. And x, I've taken 1 away from the 2, so now it's just a single x. I don't need to put a 1 there, but I can if you want to. Okay, the next term is going to be, there's no number here on the x, so I assume that that's a power of 1. So I take 1 times negative 18, that's minus 18. And I think this is where a lot of people are forgetting. I'm taking 1 away from that power, which means that's going to be x to the power of 0, which means that x is going to disappear. Don't write an x here. The x is now gone. It was x to the power of 1. This is now x to the power of 0. And the 80, there is no x there. So that would be as if it was x to the power of 0. I would multiply that by 0. That term would disappear altogether. So I've only got 2 terms in my answer. That is already dA dx, and it is as simplified as it gets. That's it. We just need to show what x will be when this is equal to 0. So I'm going to set that equal to 0. I'm going to try and get x on its own. So I've got 4x, sending the 18 to the other side. 0 plus 18 is going to be 18. And x by itself is going to be 18 divided by 4. And I'm running out of space, so I'm going to have to squeeze it into the side here. 18 divided by 4, that's going to be 4.5. Okay, so x's value is 4.5. Sorry, let's tidy that up. Okay. So when x is equal to 4.5, we've got a maximum value of a. I need to know what that maximum value is. So when x equals 4.5, what's a? Don't go into this equation and put 4.5. All you're going to get out of that is that this will equal to 0. That's how we got the 4.5. We want to find out what a is, so we go into the a formula and we substitute 4.5 in for x there. So I'm doing 2 4.5 squared minus 18 brackets 4.5 plus 80. Okay, and you're going to need to work that through. I get 39.5. I hope you guys do too. 39.5. Okay, and this is the area of, oh no, sorry, that was a different question. Okay, so 39.5 is our maximum value for A. Okay, question 5 now. This is about a particle, motion of a particle, and you have to remember that our variables are s for displacement and t for time. And we're trying to work out the expression for the velocity, given that the displacement s is equal to 10 plus 9t squared minus t cubed. So that's the displacement at different times, and we want to figure out what the velocity is at different times. So we're going to write the velocity formula. So I started by copying out the formula for the displacement, and I have to remember that the velocity is the change in position over time. Remember that ds, that's delta s, that's the change in s, over dt means the change in position over time. So the velocity is going to be just this formula differentiated. Again, t, or 10, doesn't have any t's. So that would be like t to the power of 0. When we differentiate, numbers that are on their own disappear. It's gone. So we're on to the second term. Minus, don't forget the sign, minus 9t squared. I take the power 2 times the minus 9, makes negative 18t. Now it used to be a 2, now it'll be a 1. So I don't need to put anything there. That just assumes that it's a 1. And my last term, I've got negative. Don't forget the sign. That's negative. I take the 3, I multiply it out front, so it's going to be negative 3t. It was a 3. Take 1 away from that. It's now a 2. And that's my, my formula for the velocity. So at whatever time t, we can work out the velocity. Sorry, I miscopied that actually. The original formula for s was 10 plus 9t squared. So that's going to make the differentiation positive 18t minus 3t squared. So my mistake there. Okay, so it's 18t minus 3t squared. Right now for question 6, we've got a particle moving on a straight line which is passed through a fixed point again. Displacement is s of the particle from some position 0 at time t, but here I have the velocity formula. Notice it's the same velocity formula that we just worked out. Now we need to work out the time when the acceleration of the particle reaches 0. So we need to think about the acceleration of the particle and work out t. Right, so we're on question 6 up here. This is the velocity formula. The acceleration, just like we did the velocity formula from the displacement, we needed to do the same thing for acceleration, because acceleration is a change in velocity over time. So that's dv, the change in velocity, over dt, over change in time. Okay, so we're just differentiating this again. So for the second time, that's why I always write dv dt or ds dt or dy dx, just to show that I've already differentiated once. But here for acceleration, I need to differentiate velocity. This is velocity, so dv dt, I take the power, which is 1. If you don't see a number there, it's 1. I multiply it out front, so that's 18 times 1 is 18. And the t is going to disappear because it was t to the power of 1. Now it's going to be t to the power of 0. And the second term, I take the power, multiply it out front, so that's going to be negative 3 times 2 is 6. T to the power of, it was 2, now it's 1. And I don't need to do another step to simplify that. That is my expression for the area, or for the acceleration, excuse me. But the question is, when will the acceleration be equal to 0? So I'm going to set this acceleration equal to 0, and I'm going to figure out what time does that happen at. So I need to rearrange this to find out what the time is when the acceleration is equal to 0. So I'll leave the t over here. In fact, I'll leave the minus 6t over here. And that minus belongs to the 6. If I'm moving the 18, it's a positive 18 that I'm moving to the other side. It's going to be 0 minus 18. Okay, and that's obviously negative 18. And I want the t by itself. It was minus 6t, but I'm going to go ahead and move that minus 6 to the other side. It was being multiplied by the minus 6, so I'm going to divide by the minus 6. And that leaves me with, I'm going to have to work to the side here so I don't run out of space. That is t equals 3. T equals 3 seconds. After 3 seconds, the acceleration reaches 0. So it stops speeding up or slowing down. It reaches a velocity that's constant. Okay, on to question 7. We are still looking at the displacement of a particle. Here is my formula for the displacement after t seconds. I want to find the displacement of the particle after 5 seconds, the velocity of the particle after 5 seconds, and the acceleration of the particle after 5 seconds. So I need to differentiate s to get v, I need to differentiate v to get a, and in all of those cases, I want to substitute 5 seconds into each of those formulas. Okay, so here we go. I've copied out the formula for the displacement after t seconds, and after 5 seconds, I just need to substitute 5 in for t into that formula. So that's going to be 5 cubed minus 6 times 5 plus 3. 5 cubed is 125. 6 times 5 is 30, so minus 30, plus 3. Okay, and that's going to be 95 plus 3, 98. I'm going to double check that with my calculator, and you should always double check even if you're sure. Do 125 minus 30 plus 3. Glad I checked it, but it is right. That's 98. So after 5 seconds, the displacement is 98 meters because we're talking about how far it's moved. And the displacement was in meters and the time was in seconds. Okay, part B. After 5 seconds, what's the velocity? So I've got the displacement formula here. I need to differentiate it to find the velocity formula. So V is d ds dt, which is 3t squared, right? Power out front, subtract 1 from the power. Next term is -6. The t's disappeared because it was just t to the power of 1, and there is no 3 in this. Okay, so that's my velocity, and I want to find what is the velocity when t is equal to 5. So I'm going to go ahead and substitute into that 5 squared minus 6. I put t is equal to 5 in there, and then working that out, that's going to be 3 times 5 squared is 75 minus, or 5 squared is 25, excuse me. I'm glad I'm catching these little mistakes here. I'd already multiplied by 3 in my head. Okay, so that's 25. 3 times 25 minus 6. That's 75 minus 6, and that's going to be equal to 69 meters per second. Because again, this is a velocity. It's a distance over a time. So my units of measure is some distance over a time. And this whole question was in meters and seconds, so meters per second. Finally, I'm trying to find my acceleration after 5 seconds. Acceleration is the change in velocity, so dv dt. I need to differentiate my velocity, which was this one, 3t squared minus 6. So that's going to be 2 times 3, 6t, and the 6 disappears because it's just a number. So after 5 seconds, the acceleration is going to be 6, and I replace the t with 5. The acceleration is going to be 30 meters per second squared. That's a velocity per second, right? So meters per second per second. So that's why it's squared there. Okay. Last question, question 8, and it's a bit of a tricky one, and they are tricky ones on these exams with these tiny little squares, and they didn't tell you the scale. You really have to count those squares to figure it out. But I did help you out with this a little bit. I've given you the frequency for the first bar. I didn't give it to you in a table. You had to read carefully. There are 28 customers who spent 2 minutes or less. So in this bar, I would write that that's 28. If I could, I'd write here on the screen 28. Okay? And I need to work out the frequency density for the bar showing the people who spent 0 to 2 minutes in the post office. So if I can work out what that frequency density is, I can work out what that scale is using the number of squares. If I know that scale, I know the scale for the whole graph, and I can find the frequency densities for all of these bars and the frequencies for all of these bars, and I will know everything. So always look for the information. Okay, so I'm going to work out the frequency density for that first bar. Then I'm going to notice that the height of the first bar is 17.5 squares. I told you how many squares that was to help you from counting. So that's 17.5 squares. You need to work out if that's a frequency density of this value here, how much is each square worth? That's going to tell us what the scale is. So one small square worth how much? C, use your scale you found to work out the frequency density of the bar showing people who waited 2 to 6 minutes. So that's this bar here. If I can work out how much each little square is worth, I can find how much this many squares worth and work out that frequency density. And once I worked out that frequency density, I can do part D and figure out how many people spent less than 6 minutes in the post office. That's not just the frequency of this bar, although that's what the frequency density will help me with for this bar, but I need to add that to the people in this bar as well, the 28 customers who spent who spent less than 2 minutes, because this is the people who spent less than 6 minutes. That's 6 minutes down to 2 minutes, as well as 2 minutes down to 0. Let's see the working for that. Okay, so just working with the numbers that you were given. From 0 to 2, the frequency is 28. The frequency density is the frequency divided by the class width. And here you should clearly see that the class width is 2. CW equals 2. Right? From 0 to 2, that's a difference of 2. So my frequency, which is 28, divided by my class width, which is 2, is 14. So the frequency density for that first bar is 14. And we were told that it takes 17.5 tiny little squares to get to the top of that bar. So that's the number of squares. Now I just worked out the frequency density, which is 14. And I'm trying to work out how much each square is worth. So 17.5 squares takes me up to a frequency density of 14. I need to work out what one square represents. Okay, so I need to go from 17.5 down to 1. I'm dividing by 17.5. I need to do the same thing to the number 14. I need to divide by 17.5. Not an easy division to do, so calculator, 14 divided by 17.5. Okay, and that gives me 0.8. Each square is worth 0.8 in frequency density. So 1 square equals 0.8. Not the easiest scale to work with, but you just need to count how many squares there are and then multiply it by 0.8 to find out what the frequency density that represents is. Okay, so from 2 to 6 minutes, what's the frequency density? I know that 1 square is worth 0.8, but let's have a look at the graph and see how many squares that is. Now I know what you're going to say, it's too hard, they're so small, but you need to try. To help you out here, we know that that's 17.5, so that little line above there, that's 18. So you can count from there, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I think it's 40. Double check for yourself. What would help is maybe taking a ruler and doing like this to help you count the squares, but I think it's 40. Okay, so that's 40 squares, and we want to work out what the frequency density is, because remember, each square is not worth 1. Each square is worth 0.8. So let's go back and have a look at the word. Right, so with our scale of 1 to 0.8, if we know that there are 40 squares, we need to work out what the frequency density will be. Each square is worth 0.8. I've times the number of squares by 40. I need to times 0.8 by 40. Okay, I know that 8 times 4 is 32, so 0.8 times 40 should be 32 as well. Let me just double check that on my calculator. 0.8 times 40 equals, oops, I typed that in wrong. 0.8 times 40 equals 32. It is 32. Okay, always good to check. Right, so we've got 32. Right, finally, the frequency from 0 to 6 minutes. Now I know that from 0 to 2 minutes, I was given frequency is equal to 28. Now from 2 to 6 minutes, which is the bar that we've just worked out, from 2 to 6 minutes, the frequency, I didn't work out the frequency here, I worked out the frequency density, but the frequency is equal to the frequency density multiplied by the class width. So that's going to be, class width. Now, so that's going to be 32 frequency density multiplied by the class width. This is from 2 to 6. If I do 6 take away 2, that's a class width of 4. So class width of 4, 32 times 4, that's 128. 2 times 4 is 8, 3 times 4 is 12, so 12, 8, 128. Okay, so that's from 2 to 6 though. This is from 0 to 2. So altogether, a frequency from 0 to 6, so less than 6 minutes, is 128, plus 28. That's going to be 16. Remember the 1, 5, 1, 156 people. Okay, so that's the end of our assessment number 1. And I know it's a bit challenging, but make sure you go through that carefully and you understand that, because we never know what we're going to get assessed on at the end of the year. Hopefully they tell us soon. All right, hope that helped. Good luck. Bye.